Hello and welcome to this video on how to create Linux applications using Xilinx SDK. Xilinx SDK makes Linux application development and debug real simple for Zinc 7000 all programmable devices. In this video, we will go through the features and understand the utility with a quick demonstration. Xilinx SDK supports application development in following ways. It provides Linux GCC toolchains for ARM A9 and Microplace cores. It is also shipped with a Linux root file system. That said, it also allows you to select the toolchain and root file system from custom Linux projects. This way, the created application is always in sync with targeted Linux project. The toolchain builds the application and generates an executable, which can then be run on Zinc Linux target. However, developers can also choose to generate static libraries. Refer Xilinx wiki page for more information on Xilinx Linux distribution. In the next slide, we will go through the steps involved in creating Linux application project in Xilinx SDK. Let us now look at the application project wizard in SDK. The wizard supports application project creation for Linux operating system platform and others such as standalone and custom platforms. The wizard is a simple dialog requiring one-time settings before creating the application. For Linux operating system platform, SDK enables Linux project-specific application development. In other words, this allows developers to create and build application for custom Linux projects. This can be done by specifying the system root and the Linux toolchain paths. Without these settings, SDK selects default system root as a source of headers and libraries. Xilinx SDK is shipped with three application templates. You can select appropriate application template based on the requirement. While Hello World application template can be used to test basic application on Linux target, the empty application can be a good starting point for any custom application creation. The OpenCV application template takes in an image file and generates an inverted image. SDK is shipped with OpenCV libraries to support OpenCV applications. This makes it possible to write more OpenCV applications without spending much time on gathering the resources for same. All in all, SDK enables Linux application development with these features. It supports code creation and management. It allows you to connect to remote Linux target via Remote System Explorer. It supports Linux app debug using System Debugger. In addition to feature-rich GUI-based flow, SDK also provides command line console for application creation and overall development. This can be used through SDK command line. SDK help lists detailed steps for using SDK command line. This slide presents the tool flow for overall Linux development stages for Zinc all programmable SoC. To start with, developers can configure and build the Linux kernel and the root file system using Petalinux toolflow. Then, develop Linux application using Xilinx SDK. SDK allows you to create this application from the root file system that was created as a part of first step. Now, once the application is built, you can either load the application on Linux target using Remote System Explorer or package the application using Petalinux tools. Another important stage would be to debug the application running on Linux target. For this, Xilinx supports Linux application debug through System Debugger. Let us now see a quick demonstration of Linux application development. In this demo, we will create a Linux application using Xilinx SDK and run it on Linux target. Let us start by creating an empty application project. Enter project name, select Linux as the OS platform, and now select the Linux empty application. This creates an application template with includes and source folder. Now, let's create a simple Hello World application. Start with adding a source file in the source folder. and then add hello world code. Now let us build the application. When I build this application, the tool generates necessary makefile for this project, which then builds the application to generate the executable in the debug folder. For complex projects, you can modify the makefile on need basis. Let us now create an application from OpenCV application template. Enter project name, test app image. Select Linux as OS platform. This time, let us also add path for system root from a custom project. For this demonstration, we will use the sysroot from the PetaLinux project. The tooltip shows the path which needs to be set for PetaLinux project. And now select the OpenCV application. The application takes an image file as an input and creates an inverted image for same. As we can see, the source file can be found in the source folder. This application makes use of OpenCV libraries. For such dependencies, ensure that the paths are set in build settings for this application. These are the include paths, and the libraries can be found in the set paths. For more information on these paths, refer SDK help. Let us now build the application. As we can see, the executable elf is created in the debug folder, which also contains a makefile. Let's run the application now. Before running application, ensure that the Linux target is already up and running with necessary libraries. For this demo, I have Linux running on ZC702 board. Now let's create a new run configuration for this project. First, let's establish a connection to the board. As you can see, SDK automatically populates most of the details for run configuration. Verify that the details are correct and modify wherever necessary. Now set the remote absolute path for application to be loaded on the target. This application requires an image file as an input. For this, we pass the image file name image.jpg as an argument while running this application. For this application, I have already copied the image file in temp folder in the target. Let us now run the application from Xilinx SDK. As you can see, the application generated a result.bmp file in /temp folder. Let us now verify the same on the target console. Here, the app_image is the executable elf file for the application, which took image.jpg as an input and generated result.bmp as an output, which is an inverted image. Let us now get back to the presentation. Xilinx SDK also enables you to create or import a makefile based project in SDK. This makes it easy to import an existing code onto SDK and cross-compile it for ARM A9 on Zing all programmable SoC. Alternately, SDK also allows importing the entire application project source code. For more information, please refer listed documents and videos. SDK Help is an up-to-date document which contains good information on different components of SDK. In summary, Linux application development is easy with Xilinx SDK. Xilinx SDK also allows users to target the application for other Linux projects. And on the debug front, Xilinx SDK also supports Linux application debug. On behalf of Xilinx, thank you for watching this video.